Alright, hey everybody. We are looking at proving theorems about triangles still. I'm on slide number 10. Looks like we're going to get into isosceles triangles. Now, I just said on the last video that in isosceles triangles, when you have two sides that are equal and also two angles that are equal, we happen to call those two angles that are equal base angles. So I have a feeling we're going to be looking at bunch of equal stuff in this. All right, so let's see. We got an activity, so I'm going to click on base angles here. Oh, okay, so they gave us an isosceles triangle. Let's see what we got to do with it. Find the lengths of AB and BC. What's the relationship between these lengths? What kind of triangle is ABC? Oh, well, I imagine it's going to be an isosceles triangle. Well, let's see. AB and BC. All right, so let's see. Got to find the lengths. So I'm just going to click on the actual side AB. I got 4.47 and BC also 4.47. So they are both 4.47. So what's the relationships? They're equal to each other. And that means it's an isosceles triangle. Well, let me just check. That third one can't be the same. Okay, yeah. Because if the third one's the same, it's an equilateral triangle, not an isosceles triangle. So I just needed to check really quickly. All right, so AB 4.47, BC 4.47. They are equal sides of an isosceles triangle. All right. Question number 2. Find and compare the measures of the base angles. Well, I've already told you just a minute ago the base angles are going to be equal to each other. So remember, it's the letter in the middle, so I'm looking for angle C, because that's the letter in the middle right there. And angle A, that's the letter in the middle. So I'm looking for these two angles, angle C and angle A. So angle C, angle A, that's one of the measures I'm looking for. So I'm going to come back up here and go to my angle. Remember, I got to go in a clockwise motion. So to get C, I've got to click on B, C, and A. And to get A, I've got to click in a clockwise motion. So C, A, B. Yeah, definitely. They are both the same, 63.43. And this is definitely an isosceles triangle because the other one's, that's called the vertex angle. It's not going to be the same as the base angles. So 63.43. Angle CAB, 63.43. The angles are equal. All right, question 3. Now move vertices A, B, and C of the triangle to create a triangle of your choice. Note the tool will allow you to create only certain kinds of triangles. Does the relationship between the base angles change as the vertices change? I don't know. We'll see. I'm going to come over here to click move. Okay, it makes it stay isosceles. Look, these two base angles are staying the same, and the two sides are staying the same. So it's letting me move things. It's just not letting me change it from isosceles. So no matter where I move it, the two base angles are the same, the two sides are the same. The base angles remain equal of this isosceles triangle. All right, sweet. All right, so the takeaway from this page 10 is that on an isosceles triangle, you got two equal sides, two equal angles, and the angles that are equal are called the base angles. This one's called the vertex angle. All right, so that's it for page 10.